So I'm just starting off with a clear calculator and then negative cube root. So I'm going to press the y equals button so I can start graphing. I need the negative sign in there. I need the cube root. Does anyone remember how to get to the cube root? Not second. Math button. Yep, hit the math button. And it's option number 4. Option number 5 lets you put in other roots. So 4th root, 5th root, 6th root, 7th root, that's how you would put those in as option number 5. And you would have to type the number before you did it. So if you wanted a 4th root, you would have to type a 4 before you did this. If you wanted a 7th root, you would have to type a 7 before you did this, okay? So 3rd root right here, x, and then what did it have after that? Plus 17, okay. Get out of that, plus 17. So there is our graph. Now, if you hit the graph button, you are going to see nothing because the transformation is that the entire graph has been shifted up 17. It might not be over there because I don't even know if I move the extra copies over there. It might still be over here. So we can't see anything because the graph is actually like this only goes to 10 and the graph is probably up here. Okay? So what we need to do is we're going to hit the window button because the window shows what we can see. And the window goes left 10, right 10, down 10, up 10. And we want to see more of those like up values because our graph was shifted up 17. So if I change my y max to like up 20 because my graph was shifted up 17, then I'm going to be able to see the graph. See? Now I can see that it was going up. All right. Now, if I'm trying to find the y-intercept, I'm going to be able to do that because it's actually on my screen. If I want to find the x-intercept, I'm not going to be able to do that because I can only find x values that are on the window. My x-intercept is like going to be all the way off screen somewhere. Yeah, so I need to hit the window button. I need to have more positive x values because the x-intercept is definitely off screen. So if I make my x max something like 50, just something bigger, then I can see what's happening.
So you can just choose a random number?
Yep. This is kind of like a guess and check. So I just made it 50. 50 is not big enough. You guys see that? 50 was not big enough, so I'm going to try something like a lot bigger, 200. Huh? Yeah. Yeah. I'll show you one more time. So if we look at this, I'm hitting the window button. X min is numbers to the left. X max is numbers to the right. Y min is numbers down. Y max is numbers up. So my X max right now is 200. That's not getting me far enough. I still have not crossed the y-axis. I haven't gotten to my x-intercept. I still need more numbers, so maybe I'll do like 1,000. My y-max was 20. Yeah, I made it a little bit more than 17 since the graph had shifted up 17. Yeah. Okay, so 1,000 wasn't enough. Let's try 2,000. It's still not enough. So you said you did 5,000, Kane?
Yeah.
Okay. So if I change it to 5,000. So our goal right now, we just want to see that graph go on the other side. There, yeah, you can see it kind of did it. I'm going to do a little bit more. I'm going to do 6,000. And now we can actually see that it went through. You guys see how the curve went through the y-axis? So now I can actually find my x-intercept because it went through the graph. So I'm going to say second trace option number 2 and I'm going to say, hey, graph, I want you to look for the x-intercept, and the x-intercept is between 0 and 6,000. Somewhere between 0 and 6,000, it's there. The guess is always dumb. I'm going to let it look for it. 4,913, comma 0. Yep.
Or just put in Desmos as your article.
Yeah. Yeah, Desmos would have been easier on this one for sure. So these graphs, they grow, or in this case, they decay. This one was getting smaller really, really slowly, which is why it was going to hit the x-axis. It just took a long time to do it. So, okay. And you can take the window and you can put it back to normal by typing -10, 10, -10, 10, or you can do second plus 712 and just clear your calculator and get it back to normal that way. Okay, so what I want you guys to do now, we're going to hold on to those sheets. We're not going to turn them in. I want you guys to work on 18 through 20. So we did 1 through 17 yesterday. Let's go ahead and do 18 through 20. We're just going to work on these a little bit at a time. So we've got -2, x minus 5 to the third. Okay. Ooh, you can't even see that. Okay, are we okay with typing number 19 into the calculator? Okay. And then we got it graphed. We have to find the intercepts and then increasing and decreasing, is that right? Okay. So the y-intercept is not on the screen, but you can find it just fine. There's only one x-intercept. And the x-intercept is somewhere between 0 and 10. I don't know where it is, but it's somewhere between there. So for the x-intercept, I'm just going to do second trace, option number 2. And I'm going to tell my calculator to look somewhere between 0 and 10 because it's somewhere on the right side of the graph, okay? So left bound, I'm typing 0. Right bound, I'm typing 10. I'm ignoring the guess because the guess is always stupid. 5. The x-intercept is 5. Okay, so only one x-intercept. For the y-intercept, I always type second trace, option number 1, and I plug in 0. I cannot see it on the screen. It's really high up there. 250. Okay, so the y-intercept is 0, 250. The reason that you can find it, even though you can't see it, is because the x value of 0 is on the screen. And you can always plug in values of x that you can see. So I can see the x value of 0 on the screen, and so that's why the calculator lets me plug it in. Okay, now for increasing and decreasing, if you want to draw a little sketch of it so you can use your stick figure, the picture looks kind of like this. So my stick figure, if he starts walking, is he walking uphill or downhill? Downhill. So this is like he's like sliding and he's terrified because this is a very steep slide, and then the slide like evens out for a second. He feels less terrified, and then what happens? And then it drops, and then he is still very terrified. Okay, it's a double decrease. It's just decreasing. So for increasing, I'm going to put none. It just never happens. He has a moment where he's less terrified, but he's just terrified the whole time. And this is a very, very up arrow, but in terms of left and right, which direction would it be? Is it left or right? Which direction would it more so face? Left. It's just very slightly left. Do you guys see how this is a little bit more left than that one is? So this one is, yeah, this one is slightly left. This one is slightly right. It's not very left, but it's technically the left arrow. Yeah, it's just not very extreme. So this is a left arrow. This is a right arrow. So what would we write for the decreasing interval? -infinity to infinity. It would do that if you typed -2 x minus 5. So remember, if we were to read this out loud, we would say -2 times x minus 5, which means this minus should be a little bit shorter, and this one should be long. Yeah. Yes? I think I'm all out. I know. You got it. So what you do is you take your sleeve, and you just rub it up your nose like that. No? You just rub it up. You just rub it up your nose. No? No? Okay. You don't want to just, you don't, okay. That's fine. All right. If you need to go to the bathroom, I'll send you to the bathroom to get some tissue. You don't, okay. The nose, the sleeve on the, no, not, okay. All right, let's go ahead and get these papers out. Like I said before, we are definitely working with pencil today. And then on the video, I showed you how to do it by hand, but we are actually going to use our calculators. Isn't that fun? I'm going to have you guys use your calculators for this to save us time. Okay. So, let's make sure that we are not scared of these. With those packets, we are not turning in the packets yet because we've only done 1 through 20. Eventually, we're going to finish it. So we're just going to do a little bit at a time until we're done. Okay? So hang on to those packets. I don't know how quickly we're going to do them, but eventually we're going to get them all done. Okay. Oh, also, I started calling parents last night, just of students who have lower grades. I wanted to get a feel for, from your parents' perspective, how much students are working at home. And I haven't decided everything because I need to talk to Ms. Honeycutt and see what she says. Because as a teacher, I'm kind of stuck in a hard place where the pace that we're going is uncomfortably fast for you guys, and it means that some of you guys are okay with it because some of you guys have done well on the tests and stuff, but some of you guys are dying and working on homework a lot at night, it turns out, and then like not doing well, which is not fun. And so I'm going to talk to Ms. Honeycutt because right now the pace that we're going at means we can learn everything before the EOC. That's why we're going as fast as we are. It means we can learn everything. Right. Right. So I can keep going at the pace. We can learn everything, but some of you can die. Or I can slow it down, which means that that we don't get through everything, which means that then you get tested on stuff that you've never seen, which also doesn't feel great. And the EOC is obviously important for you guys because you guys get graded on it, but it's important for the school as well. It reflects on how successful the school appears to be to the community. And the way that the curriculum is in Math 3, this is not something where it's like, oh, if they understand the math really well, then the stuff they've never seen, they could like probably just do that on the fly. It's like if you haven't seen it, you're just not going to be able to do it.
Is that one thing in the curriculum though? It's like,
The-
there's only like one question.
yeah. Yeah, and the way that this EOC is set up, there isn't stuff like that.
Really?
Everything has like chunks. It's like chunk tested. And there's some stuff that like you just have to memorize. So that's like something I'm going to bring up with Miss Honeycutt today because I just was calling a bunch of parents last night. So I just want you guys to know it's on my radar. Like I'm trying to figure out what to do. It's a hard decision for me to make because I feel like it's a lose-lose. Like no matter what, somebody's losing. And then I'm also keeping in mind that that for you guys, it's not all about the EOC. It's also about how well you perform on like the ACT and the SAT, and that you guys are in honors classes, and that for a lot of us that means like we're trying to get honors credit, and college is a thing that you're thinking about, and so how well you do on other tests matters. And you are college bound, and so there's also that to keep in mind for you wanting to learn this information for like how that bodes for the future. So I'm thinking about all of those things while also trying to keep in mind too that you guys have had bad experiences in the past, and we're trying to make up for those experiences. It's a lot for me to have as a responsibility for like your first year with a full-time teacher for some of you in a while. So I do want you to know that I'm hearing how hard it is, and I'm trying to figure out the best way to like benefit you without killing you. I just want you to know I'm aware. And that when things get difficult, you can share with me. Like Miss Rice, you're killing me. I'm dying, you know? You can share that. Okay. So one thing that we are going to do moving forward, though, one compromise that I can make is we're going to, from here forward, we're going to use a sheet of paper. We're going to take notes on a sheet of paper that we can use on the test. So I'll say one sheet of notes front and back. You can put example problems. You can put formulas, stuff like that, so that if you feel like you are brain farting or whatever, having trouble remembering things, you make the page. You get to put it on there, okay? So, and then on the day of the test, you guys get to use that. Now, when you guys take your test, I'm going to keep those sheets because I do have kids testing like later in the day, so you don't get to like share with them, whatever. But that is something that I will let you guys do as a way of saying, like, I recognize this has been really hard for you guys, and I want to make things a little bit easier. Sound good? But I'm going to talk to Miss Honeycutt and just see, like, administrator perspective, you know, like somebody in charge, what can we do? Because I, as a teacher, as an individual teacher, I'm having a hard time making the choice of like what to do to make things easier for you guys, but also like have the big picture perspective of not hurting you in the long run. Make sense? Okay. All right, let's look at these problems. Are there any on here that seem intimidating? Because we should do a couple of them together. They get a little bit crazy on the back. The first two are straight lines. And then after that, they start turning into like the parent functions we have had. It might be good to do one of the ones that just has a number, because those are ones that throw students off a lot. Which one would you guys like to do? Anybody have a preference? Preference, anyone?
Yeah, sure. How about number 12? Actually, number 10.
Okay. Let's do number 10. Okay. So number 10, we have the absolute value of x plus 1. And so what I'm going to do is I'm going to show you guys, since in the video last night I showed you how to do them by hand, today we're going to just do them in a calculator so that they are a little bit faster, and not completely in a calculator. I'm just going to say we're not going to write the points and do the transformations and all of that. So I'm going to show you guys how piecewise functions work. We're going to do it partially by hand, but also we're going to speed up the process a little bit. So the absolute value of x plus 1, what is the vertex for this graph? 0, 1. Okay. So let's go ahead and take this and graph it in the calculator. So absolute value of x plus 1, we're going to hit the math button. We're going to go over to number. And it's the very first one. Absolute value of x plus 1. Yep. So this is what the graph looks like. And then I'm going to hit, once I know what the graph looks like, I'm going to hit second graph and look at the table. And I'm going to find the vertex on the table. So 0, 1. So I have the point 0, 1. And then I'm going to graph points. Now, I'm not graphing these darkly because I know I'm going to have to erase a bunch of them. So -1, 2, -2, 3. I've got 1, 2. I've got 2, 3. And then because the middle of the graph, the piecewise function aspect of it says -3. I'm going to make sure that I get points around -3, okay? So I'm going to just go up here and just make sure I have more points around here. So -3, 4, -4, 5, -5, 6, -6, 7, and then I'm going to very lightly draw that graph in. So I'm just making something that's a little bit easy to erase. Okay? And so now that I have that, all right, so now that I have this, I'm just going to find where the x value is -3. So here's -3. I'm going to go up here and circle it. So there's the x value of -3. And then based on the symbol, should I fill it in or leave it open? Fill it in. And then am I keeping the left side or am I keeping the right side? Less than, so I'm keeping the left side. I'm going to make this side dark. And then I'm going to erase the right side. Okay? All right, on the square root part, I have the square root of x plus 2. And this one doesn't have a vertex, it has a locator point. What is the locator point? -2, 0. So I'm going to type this in the calculator. Pressing the y equals screen. I'm going to type square root x plus 2. So the square root was second x squared. So this is the x squared button. So to get the square root, we're doing second x squared and typing x plus 2. And then to see the picture, we're typing graph. And then to see the table, we're going to hit second graph. Yep. And so what I'm looking for on the tables, I'm looking for the locator point. So the locator point is right here. And I want to get other points that are around the locator point. And because the graph splits around -3, I want to try to get points around -3 if I can. On this graph, you can't, because the graph actually ends at the locator point. That's how square root graphs work. They stop at the locator point. So -2, and then I've got -1, 1. I'm not going to do any decimal points, so I'm just going to do the whole number points. So I'm skipping the decimals in between. 7, 3. So I skipped everything else. All those decimals I skipped. I would, if I had any points, -3, -4, -5, I would have graphed them if I could, but they all say error, so I can't graph anything over there. So I'm going to go ahead and lightly trace this. Now, normally my process would be on this curve, I would find -3 and I would circle it. And I would say, okay, should I fill it in or not fill it in? And you guys would say, don't fill it in, because there's no equal to. And then I would say, which part of it should I keep? And you guys would say the right side, because it points to the right. And I would make the right side of the curve dark. And so wherever the -3 was, it'd be somewhere over here. I'd circle it, and we'd make the right side dark. So I'm going to make this dark. Now in this case, it's actually the entire curve. because there's no piece of the curve that is to the left of -3. The whole thing is to the right of -3. And so we actually just get to keep the whole thing. Yeah. Yeah, so this was kind of a weird one. This is an example of a discontinuous graph. So it's not continuous. So we've talked about graphs that are continuous, right? If you can trace them without picking up your finger. So if you were to trace this graph, you could trace one piece, pick up your finger, trace the other piece. So this graph is not continuous. So we've talked about a lot of continuous graphs, but not a lot that are like this. Okay. Number 9 looks kind of weird, so I just want to tell you guys how we would normally have written it, because we don't typically write things like this. None of us would have written it this way. We would have said -x² + 4. That's how we would have written it. Or we might have said -x + 0² + 4. But we would not have written it like this. They wrote it backwards, basically. Okay. Is there another one you guys want to do? Number 3? Do you guys want to look at any of the ones that have a plain number, like number 5 or number 2?
Yeah, we can do number 2.
Number 2? Okay. So we can look at what happens when you graph just a number on your calculator. So if we graph just a 3, what does 3 do? Makes a horizontal line. So when you graph just a 3, you're graphing the line y = 3, which means you're graphing every single point where the y coordinate is 3. So it's making a horizontal line. So this one, we're making a horizontal line, y = 3. So there's my horizontal line at y = 3. I need to circle the point where the x is -4. And should I fill in that point or not fill it in? I should fill it in because it says equal to. And then am I going to keep the part on the left side or keep the part on the right side? The left side, so I'm going to make this dark. And then everything to the right, I'm going to erase. Okay? And then now I have to graph -6. So I'm going to graph a horizontal line right here. And again, I'm going to put a circle at -4. And based on the symbol, should I fill that circle in or not fill it in? Don't fill it in. And then what part am I going to keep? I'm going to keep the right side because the arrow is going to the right. So I'm keeping this part, making it dark, and then erasing the left side. Okay. And remember, these are functions, and a function always passes the vertical line test or the pencil test. So it only touches one point at a time. So right here, this is the only time it looks like it touches 2 points, but one of them's filled in and one of them is not. So it passes the vertical line test. Okay, what's the next one we should do? 3 or 4? 3 and 4 just have y = mx plus b. Those are straight lines. Y = mx plus b. So you've got your slope and your y-intercept. Number 6. So which one do we think is the worst? So we've got a straight line and an absolute value graph, a straight line and a parabola, horizontal line and a parabola, absolute value graph and a straight line. Which would you guys like to do? Number 4 or 6? Just clear it. Do 2nd plus 7, 1, 2. Then it should work. Okay, let's do number 6. So for the absolute value graph, what is the vertex for the absolute value graph? 0, 0. The vertex is 0, 0. Okay. All right, so I'm going to go ahead and graph this to get my points. So I'm typing negative, going over, I'm going to hit the math button. I went over to number, option number 1, so I can type in my absolute value. Now I'm going to hit the graph button. So there's my absolute value graph. And now I'm going to hit second graph to look at the table. And I'm going to look at 0, 0 on the table. And I'm going to graph the points. And I'm going to make sure that I focus on the points that are around an x value of 1. So this is what my graph looks like. And so what do I do with it? What should I do? I circle 1. I circle where x equals 1. Do I fill it in or not fill it in? I leave it open. And then which part do I keep? So I keep the left. The arrow points to the left, so I'm going to keep the left. And then I'm going to erase everything else. Okay. Now next, I have to graph the straight line 2x minus 4. I want the slope to be written as a fraction, so how do I take a whole number and make it a fraction? Rise over run, and so I take the whole number 2 and I put it over 1. Okay, so my y-intercept is negative 4, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So here's my line. Okay. And what do? I started at negative 4. Mm-hmm. Yeah. So now what do? I circle 1. And when I circle 1, do I fill it in or not fill it in? I fill it in. And then which part do I keep? I keep the right side. So I'm going to make this side dark. And then I'm going to erase the rest. Okay. Now, every so often, it's possible that you'll do one of the graphs and it will have a hole, and then the other graph will come in and plug that hole. Like one of the graphs will end where the other will start where the other one ended or something. And if that is the case, if you plug the hole up, it fills the circle in. Does that make sense? It would fill it in. Yep. Okay. All right. Are there any other ones that feel intimidating? Or they're written funny? We don't like how they're written. I think the rest of them are all written kind of normal. So all we have to do is just kind of lightly graph it and then circle the number, figure out if it should be filled in or not filled in. Darken the part that gets to stay and erase the rest. Okay? That's from last week. Yeah, I wrote it over here. Yeah. Number 5, remember the 3 is just a horizontal line at 3. Yeah. Okay, so go ahead and work on those.